Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy, Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Enneagon and it's by Jolly Rogers. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which in this case is a box. And we have digits in a cage must sum to the total in the top left corner and cannot repeat. So for example, if this were say an 8, this would have to be a 5 because these two digits must add up to 13. And again, you cannot have repeats in cages, so keep that in mind. So this is a simple killer cage Sudoku. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, some easy stuff. 3 unique digits adding up to 7 has to be the digits 1, 2, and 4 in normal Sudoku. So that eliminates 1, 2, and 4 in the rest of the box. 3 unique digits adding up to 24 is 7, 8, 9. So that eliminates 7, 8, 9 in the rest of the row. To add up to 15, it's either 6, 9, 7, 8, 6, 9, or 7, 8, and this can't be 7, 8, or 9. So this has to be 6 here, which forces this to be 9 here. These two digits add up to 13, and this can't be 6, 7, 8, or 9. So it's either 4 or 5 here with 8 or 9 here. These digits, you have to have, so 4 unique digits adding up to 12. It's either 1, 2, 3, 6 or 1, 2, 4, 5. Since this cannot be 1, 2, or 4, the 1 and 2 have to be here, and therefore this must be 3 and 6 here. So in column 7, we have a 1, 2 pair, which eliminates 1 and 2 here. To add up to 6, it's either 1, 5 or 2, 4. So 1, 2 cannot be here. This is 4, 5, and this is 1 or 2. Okay. Remaining digits in this upper central box are specifically 5, 7, 8, 9 because of the 1, 2, 4 triplets. And 4 has to be one of these digits here because we have a 1, 2, 4 triplet in row 2. And it has to be one of these digits here because of the 1, 2, 4 triplet in this column 6. So if the 4 was here, that would not satisfy this scenario. If the 4 is here, it would not satisfy this scenario. So this has to be a 4 here. And this cannot be 4 here. This cannot be 4 here. Okay. So the remaining digits here are 5, 7, 8, 9. We have a 5, 7, 8, 9 quadruplet in column 4, which eliminates 5, 7, 8, 9 in the rest of the column. So the remaining digits then have to be 1, 2, 3, and 6. 1, 2, 3, 4, and 6, I should say. And this cannot be... So the 5 is guaranteed to be here, so this cannot be 5. To add up to 28, you cannot have 1, 2, or 3 here. 3 is adding up with 7, 8, and 9 at maximum, which is 24. That adds up to 27 at most, so that's why you can't have that. And if you try to have 4 here, that guarantees this has to be a 7, 8, 9 triplet, but that would eliminate all possibilities for that cell. So this cannot be 4. This has to be 6, which eliminates 6 in the rest of the column. And these must add up to 22. So without a 6, because we can't have duplicates, no repeats. So that's 5, 8, 9 or 6, 7, 9. Obviously 6, 7, 9 is not allowed, so this must be 5, 8, 9, which eliminates 8 and 9 here. So this is 7, which means this can't be 7 here. This can't be 7 here. This digit is the same as that digit, so this is 8 and 9. Okay. Um, hmm. What else do we have? Maybe we can start coloring these. I don't know. 1 and 2 cannot be here. But 1 and 2 could be here. We don't know. Remaining digits in row 7 are 1 through 5, but this can't be 1, 2, or 4. So let's just go here 1 through 5, 1 through 5. This can't be 1, 2, or 4 because of the 1, 2 pair and the 4 in the column. This can't be 1 or 2 because of the 1, 2 pair in the column. And because of the 4, 5 pair in the box, this can't be 4, 5. So this is 3, which makes this 5. This again cannot be 5 then, so this is 4, 9, adding up to 13. This 4 eliminates 4 here, so this is 5 and 1, which forces this not to be 1, so that's 2, makes that 1, which makes that 2, which makes that 1. This cannot be 1, 3, 4, 5, so this must be 2. This can't be 2, 3, 4, 5, so this must be 1. This can't be 1 or 2 here, so this must be a 3, 4 pair, which eliminates 3 and 4 in the rest of the column, so this is a 1, 2 pair here. These 4 digits add up to 15 without a 1. So it has to be the digits 2, 3, 4, and 6 exactly. So this is 2, 3, 4, 6. This can't be 2 or 4. This can't be 2. This can't be 6. That means the remaining digits in the column are 5, 7, 8, 9. So this can't be 7 because of the 7 in the box. Well, we have a 5, 8, 9 triplet in this lower left-hand box. That eliminates 5, 8, 9 in the rest of the box. So this in this 5 eliminates 5 here. We have an 8, 9 pair now in the lower left-hand box. That eliminates 8, 9 in the rest of the box, so this can't be 8 or 9. This is 5, which eliminates 5 here. That eliminates 5 here. The remaining digits in the box, then, are 2, 3, 4, and 6. Okay. What about this? Remaining digits in, well, where's the 1 in this lower right-hand box? Can't be here, can't be here. These are filled out, so it must be here. So this 16 cage can also not contain a 1 because the 1 is eliminated here by the 1 in the column. Can't be here, can't be here. So then, what are the possibilities? I think it's 2, 3, 4, and 7 is the highest digit. 2, 3, 5, 6 is also works. Anyways, remaining digits in this lower central box are 6, 7, 8, 9. These cannot be 9, though. Remaining digits in this lower right-hand box are 2, 7, and 8. Okay, and this can't be 2 because of the 2 in the column. We have a 6, 7, 8 triplet, which eliminates 6, 7, 8 in the rest of the row. So this cannot be 6. This is guaranteed then to be 2 here. So this is guaranteed to be 2. This is guaranteed to be 6. This cannot be 6 because of the 6 guaranteed in the box. This can't be 2. This is also guaranteed to be 6 here. And this is guaranteed to be 2. Can we ever have digits 6 digits adding up to 16 with a 3 starting as a digit? That would be 3, 4, 5, 6, which is 9 times 2, which is 18. So no. So the 2 definitely has to be one of these digits here, which eliminates 2 as a possibility here. Where's the 2 in this lower right-hand box? It must be here. So we're guaranteed a 2 here, we're guaranteed a 2 here, which eliminates 2 in the rest of rows 4 and 5, because we have a guaranteed 2 here and a guaranteed 2 in this one of these two rows. So this cannot be 2, this is 1, that's 2. Again, this is 2 through 7 at most. And neither of these could be 2, this can't be 5, this can't be 4, this can't be 6, this can't be 3. This can't be 6. Hmm. Where is the 1 in column 3? Cannot be here because of the 1s in the rows. Can't be here because of the cage. Can't be here because of 1 in the box, so this must be a 1 here. Where's the 1 in this right central box? Cannot be here. Cannot be here because 1's in the row. Can't be here or here, so it must be here. And we have 8 1s. We know where the last one has to be. It has to be there. Okay, this 9 eliminates 9 from being here. Um, So to add up to 16, we have 2, 3, 4, 7, or 2, 3, 5, 6. I don't think we have... 2, 3, 4, 7, 2, 3, 5, 6. We can't have 2, 4, because 2, 4, 5, 6 is at minimum 17. So we're definitely guaranteed a 2 and a 3 here. Okay. Remaining digits in column 3 have to be 2, 3, 4, and 6. This can't be 2 or 4 because of the 2, 4 in the row. Well, so we have a 3, 6, 3, 6 pair in this upper left-hand box. That eliminates 3 and 6 in the rest of the box. So this can't be 3 or 6, it's 4. This can't be 3, 4, or 6, so it's 2, which means this cannot be 2 here. Where's the 2 in this lower left-hand box? It must be here. So that eliminates 4 in the rest of column 1. Where's 4 in column 3? It must be one of these two digits, so this cannot be 4 here. Where is the 3 and the 6 in row 3? Can't be any of these because of the 3, 6 pairs in the rows. Or sorry, in the boxes. So 3 and 6 have to be some combination here. And this can't be 3, this can't be 6. The remaining digits are 5, 7, 8, and 9. This can't be 5, this can't be 9 twice. Where's 4 in row 1? Cannot be here because of the 4s in the boxes. Can't be here because that's filled. Can't be here. Sorry, can't be here because of the 4 in the column. So this must be the 4 here, which eliminates 4 as a possibility here. So 2, 3, 4, and 7 would require the 4 to be here. So this can never be 7. And 2, 3, 5, 6 would have to have 3 here, 2, 3, and this be 6 there. Okay. We have all the 1s now. Do we have all the 2s? We do not. We have 7 of them, and we know the 2 has to be here and here. 3s, we probably don't have very much information. Nope. 4s, we still don't have that much information either. 5. Remaining digits in this upper left-hand box are 5, 7, 8, 9. Okay. Is that hopeful? I don't know. Okay, so let's mark these digits. So we're going to mark this green and orange here for the green for the 3 6 pairs. This has to be one of these is green. So this must be the orange one. This also must be the orange one. And the green one is here. Does that help us much? I don't really know. Where is the 9 in column 6? Cannot be the filled in digits. Can't be here because this cage no longer can have a 9 in it. Can't be in this cage, same reasoning. So the 9 cannot be here, 9 cannot be here, so it has to be here. That eliminates 9 in the rest of the row. So the 9 in row 5 has to be one of those 2 digits here. Okay. Can we color these? Let's make this red and this yellow. So that means red has to be one of these, which forces this to be yellow. This is yellow because it can't be red. Yellow has to be one of these two because it cannot be here. So then yellow has to be one of these two here. Okay. Yellow has to be one of these two here. We don't know which. Red is one of these 3. Red is also one of those 3. We don't know which. Where's 9 in column? Okay. Where's 9 in column 7? Can't be here because 9's in the boxes, so it has to be here. Which means the yellow 8, 9 is 8. So this can't be yellow. Therefore, this is the red. This can't be red then. This can't be red. So red, can it be here? It has to be here. So this is not yellow, which makes this yellow. Okay, so then we know yellow is one of those two. Yellow has to be here. The reds are all here. We don't know which red this is. So the reds have to be 9. The yellows have to be 8. This must be then a 5. So this cannot be 8 here. This can't be 8 or 9. So this is 5. Not 5. This is 7. So this cannot be 7 or 8. It's a 5, 9 pair. This can't be 5. So this has to be 3 and 6. And this can't be 6. So this is 3. That's 6. 3 can no longer be here. So where is the 3 in this cage? There has to be 1. It has to be here. So this is 3, which eliminates 3 here. This can no longer be 8, so it's 7. This can't be 7 or 8, so it's 9. That eliminates 9 here. The 9 eliminates 9 here, so it's 5 and 9. We have now 8, 9, so we know where the last 9 has to be. It has to be here. So this cannot be 8 here. This is a 6, 7 pair, which eliminates 6 and 7 in the rest of the row. This can't be 7. That's 8, which makes this 7. This can no longer be 7. This must be a 2, 5 pair, so it's 2, 5, 3, which makes this a 6 to add up to 16. 6 eliminates 6 here, so it's 2, which makes this 3, which makes that 6. So this is not the orange here. Green is one of these. This can't be 9. This 2 eliminates 2 here, so it's 5 and 2. That leaves this digit as an 8. 8 eliminates 8 here, so it's 7 and 8. The orange digits are 3. That makes us 4, so this cannot be green, so this must be green here. And must be a 6. 3 eliminates 3 here, so it's 4 and 3. 3 eliminates 3 here, so it's 6 and 3. 6 eliminates 6 here, so it's 7 and 6. And the rest we just learned from Sudoku. This has to be a 7. This is a 5. We have 3 and 8 remaining. This can't be 3 because of 3 in the row, so it's 8 and 3. This is 4 and 7. 7 cannot be here because 7 in the row, so this is 4 and 7. Remaining digits in row 4 are 4 and 5. Huh. Okay. Remaining digits in row 5 are what? 4 and 7. And this can't be 7 because of 7 in the column. So this is 4. That's 7. 4 eliminates 4 here. So it's 5 and 4. That leaves this as a 5 and this as a 6. And that's a solution. Yep, straightforward killer cage Sudoku. You just have to know the actual values to add up to these things, and then just use like naked triples to remove possibilities. Naked triples and naked quads to remove possibilities. And that's pretty much it. I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.